Have you ever built a really cool AI model and thought, how do I turn this into an actual business that people can pay for? Well, today, that's exactly what we're going to break down. We're going from a simple piece of code to a full-blown, production-grade, software-as-a-service product.
And this, right here, this is the core of the problem, isn't it? You've got this brilliant AI model, maybe it removes backgrounds from images or writes poetry, whatever. But sitting on your computer, it's just technology. It's not a product. The real magic is building the entire system around it so that real users can log in, pay you, and actually use it.
So, here's our game plan. We're going to tackle this in 3 big steps. First, we'll design the back-end architecture, what we're calling the asynchronous blueprint. Then, we'll build the secure front door for our users. And finally, we'll get into the good stuff, automating payments to turn this whole thing into a real self-sustaining business.
All right, let's start with the foundation. Look, if you try to run a heavy AI task on a normal, everyday web server, you're going to have a really bad time. That's why we need what's called an async blueprint, a system that's literally designed to handle these slow, heavy jobs without ever making your user think the website is broken.
Here's exactly why the old way just completely fails. So a user uploads their image, and their web browser just waits and waits. After maybe 10 or 15 seconds, it's probably just going to time out and throw up a big, ugly error page. To your user, your amazing AI app looks totally busted, even though your server is still chugging away in the background. We need a much, much better approach. And that approach is called the asynchronous worker pattern. It sounds kind of fancy, but the idea is actually super simple. Think of it like a coat check at a restaurant. You hand over your coat, you get a little ticket, and you go enjoy your meal. You don't just stand there watching the attendant hang it up, right? You come back later with your ticket. Our app is going to work the exact same way.
Okay, so let's actually trace the flow here. First, the user uploads their file, and boom, instantly gets back a job ID. That's their ticket. The main API server doesn't do the heavy lifting at all. It just sticks the job into a queue. Then, a totally separate process, the worker, grabs that task, runs the heavy AI model, and saves the final result. All the while, the user's browser is just politely asking the server every few seconds, "Hey, is my job done yet?" Until finally, it gets the finished product.
So the absolute key here is this separation of duties. The queue. Think of that as the waiting room. The API server is just the super fast traffic controller, pointing jobs into the room. And the worker, that's the expert in the back, pulling jobs one by one and doing the actual time-consuming work.
And this is the tech that makes it all happen. We use Fast API because it's built for this async speed. Redis is the perfect, lightning-fast waiting room. You absolutely need a solid database like PostgreSQL for user data. And here's a little pro tip for the AI itself. Converting your model to a format like ONX can literally make it run 2 to 3 times faster. That can save you a ton of money on server costs down the line.
Okay, we have our powerful engine. Now we need to build a secure and friendly front door. This is where your users are actually going to interact with everything we've built, so it has to be absolutely solid.
The foundation for security in pretty much any modern app is the JSON Web Token, or JWT. It's simple. After a user logs in with their password once, the server gives them a temporary digital key. From that moment on, every time they make a request, they just flash that key. It's like a hotel key card. You use it to prove you're allowed to be there without having to check in at the front desk every single time. Now, the front end isn't just about making things look pretty. It has to have some really important features. That smart polling, that's the code that keeps asking, "Is it done yet?" Protected routes are crucial to make sure only paying, logged-in users can get to the good stuff. And a usage meter? Oh, that's huge. Showing a user they've used 45 out of 50 credits creates this natural urgency to upgrade. And of course, you got to show them a history of their past work.
All right, the app works, it's secure, users like it. Now for the most important part, turning this cool project into an actual business that can pay for itself. We need to automate payments.
And this choice is way more strategic than you might think. See, with services like Stripe, you are the merchant of record. That means you are legally on the hook for handling sales tax in every single state and country your customers are in. Trust me, it's an absolute nightmare. But with a service like Paddle, they are the merchant. They handle all of that global tax complexity, and you just get a nice, clean payment. For a small team, this is a total game changer.
Now, I need you to listen closely, because this is probably the single most important rule in this entire process. When a user pays, their browser gets a little success message. You can never, ever trust that message to give them credits. A savvy user can just open up their browser's developer tools and fake that message, giving themselves free access forever.
The only thing you can trust is a secure message sent directly from the payment provider's server to your server. And that secure server-to-server message is called a webhook. Just think of it like a certified notarized letter sent directly from Paddle's bank to your server's bank. It's digitally signed, it's verifiable, and it cannot be faked. When your server gets that webhook, and only then, does it know for sure that the payment was real and it's safe to add credits to that user's account. So how do we actually track those credits? Well, the simple, rookie way is to just have a number in your database, like credits equals 50, but that's super fragile. The right way, the professional way, is to use an audit ledger. You never change a number, you only add new lines. Plus 100 for a purchase, minus 1 for using the service. This creates a perfect, unchangeable history of every single transaction, just like a real accountant's book.
Okay, let's walk through a super common scenario. A user is loving your app, they're in the zone, they're getting work done, and then they hit a wall. They're out of credits.
So what happens next? This is a really critical moment. Do you just pop up a boring little red error message that says insufficient credits? I mean, that's what most apps do, but there's a much smarter way to handle this.
The pro move is this. When the API tells the front end the user is out of credits, don't just show an error. Automatically redirect them or pop up the pricing page right then and there. Why? Because you have caught that user at their absolute peak moment of intent. They want to finish what they were doing right now. Making it dead simple for them to buy more credits at that exact instant is one of the best things you can do for your business.
So let's wrap it all up. We built this thing in 3 layers. First, the blueprint, a solid, asynchronous system that won't fall over. Second, the interface, a secure front door for your users. And third, the engine room, where we automate our payments with trusted webhooks and a rock-solid credit ledger. That right there is the journey from code to commerce.
And that brings us to one last thought. You've done it. You have a real working app that makes money. But the journey's not over. What happens when you go from 10 users to 10,000? Well, the next set of challenges, scaling, deployment, monitoring, that's where a small app becomes a true, robust enterprise. But that's a story for another explainer.